Hey everybody, it's Mr. Carr again. Today we're going to be talking about 10-1 day 2. Previous lesson we talked about arithmetic sequences. Today we're going to be talking about geometric sequence. So a lot of the same terminology we used before is applying today. Things like sequence, elements, terms. What we're looking at today though is a different type of pattern. Instead of adding or subtracting the same number, we are going to be doing a sequence where we're going to multiply the previous term by the same number every time. So instead of adding or subtracting, we're doing multiplication. So for example, here, every step along the way is being multiplied by 2. Okay. That value of multiplying by 2 is what's called a common ratio now instead of a common difference. So that is the common ratio is the constant that is multiplied to each previous number. Okay. So very quick one today. We're just going to go over 2 examples of setting up our geometric sequences and how we can use those patterns. So again, determine whether the sequence is geometric. If it is, determine the common ratio and list the next 3 terms. So here is one key that might make this easier if you're having trouble. Common ratio is always going to be the division of consecutive terms. So what I mean by that is if I take 20 divided by 8, and let's see what that is for a common ratio, or what that is. So 20 divided by 8, if I just reduce that, that's going to be divided by 4, it's going to be 5 over 2. Okay, so 5 over 2 is that as a reduced fraction. But let's check that between these two now. So let's try, is 50 over 20 the same thing? And it is 5 over 2. And my last one, 125 over 50. Okay, so we're checking this one and this one now. So does that reduce to the same thing? So if I divide everything by 25, I do get 5 over 2. So that means yes, it's geometric sequence. So yes, it's geometric sequence with a common ratio. Oops. Common ratio of 5 over 2. So we can have common ratios that are fractions. That's totally fine. If I want the next 3 terms, I'm going to do the same thing as I did before with my arithmetic, but now we're just going to multiply by 5 over 2 for each step of the way. Oops. Okay, so I'm going to take 125. 125 is multiplied by 5 over 2. Excuse me. Okay, so if I take 125 times that, whoops, I'm going to get 625 over 2. Okay, we're going to multiply that by, whoops, 5 over 2 as well. Okay, so this one will get, so again, what I'm doing is I'm doing each of these steps here. I'm multiplying by 5 over 2 for each step. So if I multiply by 5 over 2, I get 3,125 over 4. And I do the same thing one more time. Sorry about that, just getting my calculator. Okay, 1 second. My calculator does not want to give me the fraction answer, so we're going to do 3,125 times 5 is going to give me 15,625 over 8. Okay, so those are my next 3 terms. So again, every one of these was the result of multiplying by 5 over 2. All right. Determine whether this one is. So again, we're going to confirm this. If we look at our numbers, let's check consecutive terms. So 30 divided by 19. Okay. In case it might help, I'm going to just turn into a decimal number real quick. That is 1.579. Okay, I'm just leaving it like that just to compare when I get to the next step. So 41 over 30. So 41 divided by 30 is 1.36 repeated. So what that tells me is no, it's not geometric here. Okay, and that's it. Now, we did not have an example. Hey, you know what? Let's just do this as an example because this is a good one right here. Determine whether this sequence is geometric. Okay, so instead of a check your own progress, you want to pause it and try it out on your own, go ahead. But notice it's going to be a little bit of a weird one here. Okay, oops, number 16 and then 32. So if I look at this, and I'm going to look at what is my consecutive terms. So 8 divided by -4 gives me -2, right? Then I do the same thing with -16 divided by 8, also -2. 32 divided by -16, also -2. So in this scenario, my common ratio is actually, whoops, didn't want to do that, is actually a negative number. That's fine. So yes, it's geometric with a negative common ratio, which means my 3 other steps are just going to multiply by -2 every time. So we can have negative numbers as our common ratios. So if I do it the first time, I'm going to have a -64 and a positive 128, and then a negative 256. There's my 3 numbers there. Okay, one other example, and I just want to do that real fast just because it comes up. If I do something like this, let's say I have 64, 32, 16, 8, and so on. If you do your common ratios here, and I do 64 over 32, that is 1/2. Sorry, no, did that backwards. 32 over 64. I meant to do consecutive, okay? So 32 over 64 is 1/2. If I do 16 over 32, also 1/2. And if I do 8 over 16, that is 1/2. So with our common differences of arithmetics, we did adding or subtracting, but with our geometric, we don't normally say division or multiplication or division for our pattern. Instead of division, we're just going to keep it in terms of multiplying, but we're going to multiply by fractions when it's a case like this. So my patterns here are just multiplying by 1/2. Okay, so some weird ones here, we can either multiply by negatives like this one, or we can multiply by fractions, which looks like it's a division pattern, which technically is true, but we're going to multiply by a fraction that's less than 1. It kind of decreases the number. So any kind of fraction, okay, any fraction that causes an increasing, or in this case, like a decreasing kind of scenario. All right, and that is it for our geometric sequences introduction. Again, just like with arithmetic, we're going to go more in depth into these so we can really model them with their own equations and really understand them a little bit more in depth in the future. But that's for today. Take care, everybody.